So if you want to look at the index of the data frame, you can call it by using data frame.index. Similarly, if you want to look at columns, okay, you can say IBM HR.columns, and you can get all the columns. So these are the column names. And similarly, if you want to look at the index, you can call the index by calling dot index. So it says it starts from 0, stops at 1470, the step size is 1. So this is just like, if you want to have a range of numbers, say for example, x for x in range 0 to 10. Here, the 1 refers to how many numbers that you want. Say, I think we discussed this earlier. So it will take a step size of 1 and it will start from 0 to 10. So it will not include 10. So you get the number as 9. So if you want to see like a step size of 2 or 3, you can also look at that. Okay, but just make sure that whenever you try to refer, if you want to rename the index of the data frame, make sure that the index length and the number of records in the data frame match. So if I want to create random index, so what I'll do is I'll import one more module called random. So when I import random, and I'll say random.rand int, I want to take a random number between some numbers, right? Say I want to say, let us say, want to take numbers between 999 and 100. So if I do that, it will give one random number. So every time I call it, it will give some different random number. See, every time I call it, you will find a different random number like that. So what I'm going to do is I'm going to call this particular code n number of times. How many number of times I want to call it for how many records I have, that many times I want to call. So how can I do it? I'll say I'll take a list. Again, this is called as a list comparison. What you see here, between square brackets, you can write a for loop. Similarly, what I did, I'll have taken this random number. I want to repeat this random number for a size equal to my data frame shape. So if I look at data frame shape, this is my data frame shape. Okay. This is my data frame shape. But if I want to look at how many number of records are there, I'll call the first index by using 0. So I have 1470. So you want to call this particular rand int 1470 times. So how do you call it is by doing this simple list comprehension. So what will happen?
Why?
You will. So what I'm trying to do is I'm trying to rename the index. I initially have an index like this, right? From 0 to 1470. So what I'm doing is instead of having that, I can create a random index by doing this. This is not necessary, but just in case if you want to rename the index, you can always do that by doing this. IBM HR.index is equal to the list of numbers. So in this case, I have taken random numbers, so it will do that. And when I do it, you can see that the index has changed. Okay, now the index is like this. On the other hand, you can also make one of the column as index. So for example, I have education field. If you look at education field, yeah, I have education field as the column. Now I want to use this as an index. We might be doing this because, just in case if you want to use this column as an index for future subsetting and all, we can do that. So how you can set a column as index is this. I'll say data frame set underscore index followed by the column name. Why you say drop equal to true is that whatever index is there available previously, I don't want to store it. I want to just drop it. So I'll say drop equal to true. And then when I click this, you can notice that wherever you have this education field, you see that life sciences has now become as an index. Okay, this index of course has repeated values. In few cases, you might not want to have repeated values. In few cases, you might require repeated values based on what logic you're trying to use. Okay, we already discussed this dot columns. You can also set different set of columns. Say if I want to rename all the columns, just like how I did for indexes, right? I can say columns is equal to, again, it should match the number of columns this time. So if you put some list here, it should match the number of columns. Okay. I'm not going to rename the columns now. There is also possibility of renaming couple of columns that I'll tell you later on. I think we already discussed about this D types, wherein you can see most of the data types of integer, object. I don't see a float here, but if there are any decimal values, we can also have float. One column can have only one index. I mean, one data type. Say, for example, couple of values are integer. Say I have 5, 4, 3, and then I have a here, and then I have 10, 9, 8. So just because there is one string here, all this column will be referred as string data type or object. It cannot treat these values as integer, this value as string, and these values as integer. It cannot do that. So you can have only one data type for one column. You can change it if it permits. Say, for example, if I want to convert this to integer, it will fail because you already know a cannot convert to integer. That's not possible. So this will be object data type. If you want to convert this to int, you might have to treat this typographical error. Probably this is a typograph because when all the values are integer, why this value is left alone as string? This could be a typographical error. So whenever there is a requirement for cleansing the data, you might have to do it. So that is the reason why we need to understand how to subset the data and how to go and replace only this particular value. So I don't want to go and replace all the other values. Only at this particular fifth record, I want to go and replace it. So how you're going to do with it, we'll slowly see. So for that, you will have to get used to pandas. Okay. Now we'll discuss about subsetting the data. So far, we have seen how to map new index, how to get all the column names, how to get all the indexes, how to fetch only one column in the data, or how to look at number of rows and number of columns. Now we are looking at subsetting the data. So we have a big data frame. In that particular big data frame, we want to take only a chunk of it. So how do you take it? So notice that we have already mapped one column as index. So I have marked it as IBM HR2. In this IBM HR2, I will use the indexes for subsetting. You can also subset without using the index, but given a case that you already have some indexes in with this categorical data, you can do that. So how do you do that? Say, we'll be using .log for that. Before that, I want to show you IBM underscore HR. And if I want to fetch only first two records, I can do this. Okay, it will fetch only first two records. When I choose only first two records, notice that the index is not 0 and 1. So if your data frame is not sorted on the index, it doesn't bother. It will still fetch the first two records. It is not looking at your index number. On the other hand, if I want to choose a specific index, let us say I'll choose 2 here. Let's see if it can get. Now it is looking for a specific index. Okay. Now it is looking for when you have a slicing operator. This is a slicing operator. When you have a slicing operator, it is not bothered about the value that is set here. It is simply getting first two records. How I can say it is a first two records is I have printed IBM HR somewhere. Yeah, the first record in the index is 3595 followed by 5906. So when I say first two records using the slicing operator, it will fetch only those records, irrespective of whatever the index value is. But when I look for a specific value called 2, it is looking at particular value and it says the key error. Okay, it did not find 2 anywhere here. Similarly, you can also use .log. Okay, now I'm going to IBM HR2. If you remember, in IBM HR2, I have index value as education field, and in education field I have life sciences, other, medical, and many other values. So what I'll do is I'll use .log, and I'm not using any slicing operator, remember. So it is looking for specific value called life sciences in the index. So when I call this, it will fetch all the records where my index value is life sciences. So this is one kind of subsetting. So if I can go and look at shape, it is saying that for life sciences, I have 606 records. So this is how you can subset the data using an index. This is a common method of how we subset the data. Why I'm telling specifically about subsetting the data is because you might have n number of different records. Okay, every record might have its own reference to a different observation. Say for example, couple of observations belongs to pineapple, couple of observations belong to kiwi, couple of observations belong to say green apple. So based on the record observation, you might want to subset the data and look for patterns only in this particular subset. So kiwi might have its own patterns, pineapple might have its own patterns. So if you handle both kiwi and pineapple at once, then your model will not, it will have a lot of variance because it is trying to balance all the kiwis, all the pineapples. So if you want to reduce the noise, you might have to look for specific patterns in that particular category. Okay, we'll discuss more about this when we are going to machine learning part. But for now, this is how you can subset the data using the index. I can also say subset the data based on the value. Say, for example, I have a column called department. I look at department somewhere. Yeah, I have department column here. In this department, there are a couple of fields like sales, research and development. For now, I see only two values, sales and research and development. So what I can do is I can subset the whole data frame using a column condition. So I'm saying that my column department should be equal to sales. When I subset this, it will fetch all the sales department. Okay, this is one way of subsetting. So first subsetting was based on index, where I used .loc. Second subset is based on value or condition. So I'm looking for a column called department, and I want to fetch all the records where the value is equal to sales. Say you might have a requirement of having multiple conditions. If I want to have multiple conditions, I can use .in. Dot is in, I will say, a list of values. Notice the syntax difference, okay? And in this, I have research. What was the spelling mistake? Okay, it's just research and development. Let me copy it. Research and development. So what it will do, it will look in this column and it will fetch all the records where the value is sales and research and development. On the other hand, you can also have other conditions like not in. Say, for example, I don't want to fetch those records. I want to exclude wherever the value is sales and research and development, not. So wherever you have this kind of, okay, not in doesn't work. So the other way of treating not isn't is using a tilde symbol. Okay, it will apply a not condition and it will fetch all the values. So you can see human resources, all of them are human resources. Okay, this is one other way of treating a not in condition. So whenever you have a tilde symbol, it will apply the not condition out of it. Okay, and you can use .loc to fetch multiple values, same like how we did for isn, right? I'm looking for department, I'm looking for sales and research and development. So that is why you get all the values where sales or research and development is present. Similarly, in index also you can do that. So how you can do that? I can say .loc. Previously I was using only single square bracket. Now I will be using two square brackets and I'll say list of values. So this is a list of value. Okay, I can say LOV is equal to, LOV stands for list of values, which is a normal term in UI cases. So I'll put this, sorry, I should be using a single square bracket here. And in this, I'll say LOV. So you'll get all the values where you have life sciences and marketing. So .loc, when you use it for list of values, it will fetch all those values where the index is matching with the value. Okay, so here my index is life sciences. Life sciences is present in the list of values, so it is getting it. Similarly, marketing also, it is able to fetch. Say now, previously what we saw, based on a given condition or based on a given index, you're trying to fetch all the columns. Say now your requirement is to fetch only couple of columns. So how do you do that? Okay, now I can say, again, I'm going to use dot lock. In this case, I'm going to pass two values. So how the dot lock refers is, say you have a data frame, IBM HR. The easy way of understanding is, in lock, you will be passing two values. First value will be your indexes, and second value will be your columns. Okay, yeah, as simple as that. We are passing two values. First value will be your indexes, second value will be your columns. Say in the first value, I want to use couple of indexes. So again, what I'll do, if I want only one index, I can copy this. If I want only one index, say I want to use only life sciences. In that case, I'll not be passing a list. I'll be passing a single value. Okay. In second, I'll be passing list of columns that I want to use. Say, for example, here also I want to get only age. Now this is matching. You have your index called life sciences and your column called age. Whenever there is a requirement to fetch multiple indexes and multiple columns, that is where you'll be using list of values. So here you have a list. The first, before the comma, you notice the syntax, right? The first position is indexes. So in the first position, I will be passing the list of values which I'm interested in. So I'm interested in life sciences and marketing. So this is one list that I'll be passing. Second list is the list of columns. So I want to look at age and attrition. So when I call that, you can see life sciences and marketing, age and attrition. So you can use dot lock to fetch subset of indexes, subset of columns to look at only that particular data. Okay, sometimes it will be very clumsy for you to look at all the data because you have so many columns. Say if you're looking at what is the impact of age on attrition. Okay, this can be a question from the business domain saying that I want to understand how age is impacting attrition rate. So you can look at that particular column called age with attrition. Again, you have some more features to it. You're looking only in specific departments like life sciences and marketing. So based on the ask, you can subset the data and you can use only this particular data for your building your models. So we'll discuss about models at a later point. So as I said, if you want to use dot lock and you want to subset the indexes and columns, this is a syntax. So I'm going to call all the indexes, all the columns. So I'll be using colon dot comma colon. Okay. So if when you use colon, it will fetch all the rows and all the columns. Say for example, if I want to fetch only these rows, again, I want to fetch only these columns, age and attrition, but I want to fetch all the records. So what I'll be doing is, I'll be copying this. Instead of second column, I'll be using the columns which I want to fetch. So I want to fetch age and attrition. So I'll replace the column with age and attrition. So I'll replace this column value. So you can get all the records for age and attrition. That is how you can see the length is matching 1470. And previously it was getting only 765 rows. That is how you can subset the data. These are very common things. The more you practice, the more you'll get used to it. Okay. And every topic that I'm going to tell today is very important. Wherever you're handling the structured data for your machine learning purpose, be it categorical or continuous values, this is a common thing because you're going to subset the data and then you're going to cleanse it. When I mean to cleanse, you might be dealing with replacing all the outliers, you might be dealing with replacing the null values, or you might be converting couple of text to numbers. Say for example, I have in index I have a b c d, so wherever a is there I want to go and replace with 0, wherever b is there I want to go and replace with 1. So based on the use case, you might subset the data and replace it. Okay, as we move forward, when I'll be explaining about machine learning, again we'll be going through all of these one more time, but I want you to get used to it. That is why I'm going to explain all of this. Okay, let us take one simple example wherein I'm taking a temporary data frame where I have animal count, location, and ID, and this time we have a little bigger than the previous records. So if you look at the records, we have 5 records and 4 columns. So when I use dot log, you can see that all of them are coming. I use dot log, I'm saying colon, comma, colon. I'm getting all the records and all the columns. Specifically, if you want to look at records 2 and 4, say for example, I have indexes 2 and 4. If I want to get it, I can use dot log. This time I have used double square bracket. So when I say double square bracket using colon, it will fetch only the third record and the fifth record. Just notice that I did not pass this. You might have a question that I did not pass this. It is the same thing. So Python understands that you're trying to refer to get all the columns. Okay. So this code and this code are both same. So if I do not place any second indicator, it means that you're trying to fetch all the columns. Okay, when I reference dot log, it is looking at third record and fifth record and it's fetching only the third record and fifth record. Similarly, if I use dot log with couple of columns and couple of indexes, it will fetch first record, sorry, it will fetch the second record and fourth record, and it will fetch only animal and ID. So it is looking at animal and it is ID, and you can see 1 and 3 here. When you use slicing operator, look how it performs. So when you're using dot log with slicing operator, it is fetching 2, 3, and 4. It is starting from 2. It is also including 4, 2, 3, and 4. So we have something called as iloc. Okay. Now, so far we discussed about dot log. Now let us discuss about iloc. There is something called as iloc. Okay. When I use dot iloc, it doesn't include 4. Okay, it includes only 2 and 3. I'll discuss more about iloc. Iloc doesn't use indexes. Okay, though you see that it is having 2 and 3, but it is not using indexes here. I'll tell you how. Okay, let us do one thing. Let us sort the data frame based on animal. Okay, when you go and sort the data frame, what will happen is it will sort this particular column on the alphabetic order. So how to sort using a column is by doing this. Data frame dot sort underscore values by equal to. So you want to sort the data frame. How you want to sort? By using a column. Okay. If you want to sort using 2 columns, you can pass list of values here. Okay. If you want to use by single column, I'll say just animal. But if you want to sort using more than 1 column, then you'll have to pass a list of values like this. Okay, for that matter, you can include this also. I'll say a list of values like this. And I want, as I said, it is ascending equal to true and in place equal to true. I'll tell you about why we are using in place equal to true. So when I sort it, you can see that the animal column is sorted in the alphabetical order. C followed by D, followed by G, followed by S. And you can see the indexes are jumbled now. 0, 4, 1, 3, and 2. Indexes have got jumbled, and the ID is also all other records are also jumbled because the ID was previously 1, 2, 3, 4, 5. Now the ID is 1, 5, 2, 4, and 3. Okay, I'll explain about in plus equal to true. Don't worry about it. So for now, what it did is I simply sorted the data frame, and you can see this is how the sorted data frame looks like. After sorting, let us use the same code what we saw earlier using dot log and dot iloc. Now, when I use dot log, on this new data frame, notice how the indexes have 0, 4, 1, 3, and 2. When I use dot lock, I want to fetch all the values 0 to 4 in the index. But the moment it finds 4, it doesn't fetch 132. Even though 132 is less than 4, it does not fetch. The moment it saw 4, it fetched only 0 and 4. On the other hand, if I say one slicing to 2, because 3 is available between 1 and 2, even 3 got fetched. So these are the common mistakes. So whenever, if your index is not in a continuous pattern, you might end up applying the data to wrong records. Say my intention was to fetch only for records 0 to 2. What I want to do is first record, second record, and third record. Only for these 3 records, I want to go and change the values. But when you're using dot lock, and if you did not notice that the index is having a jumbled values, then you'll end up replacing more than the expected records. Okay. Similarly, if you look at dot iloc, okay, in dot iloc, it doesn't care about index values. What it cares is the record numbers in actual. So when I go and print dot iloc 1 to 3, when I say 1 to 3, what happens is it starts from 1. You have a 0th record, you have a 1 record, 2 and 3. Because you're slicing 1 to 3, it will start from here, the second record. You also include the third record. It will not include the fourth record, which is 3. It will not include this. So you'll not see this record, you'll not see this record. You'll see only these 2 records. Okay, I'll explain this one more time. Let us say, let me clear this. Please listen to what I'm saying. I have index, I have row count. Row count is what I counted. Index is what is available in the data frame. So if you notice what is available in the data frame, now this is my index. 0, 4, 1, 3, and 2. These are my indexes. You notice this? These are my indexes. Now, what is the row count? Row count is 0, 1, 2, 3, and 4. When I use dot iloc, it refers to row count, which you do not see. When I use dot iloc, it refers to row count. So when I say 1 colon to 3, it will include the second row. It will include the third row. The fourth row is not included by default. So this will not get included. And even the first row is also not included. Of course, the last row is also not included. That is why you see column row index number 4 and index number 1. Okay, let's see that. So when I use dot iloc, I'm saying 1, 2, 3. You notice the 4 and 1 is coming. You have index 4, you have index 1. That is what I told you. You have index 4 and you have index 1. Try out with different values when you practice it today, and you will notice the difference between iloc and dot lock. Always keep in mind, dot iloc refers to the record count. Lock refers to indexes. So if your index is not in continuous or ascending order, it might skip couple of values. It will not sort it for you. It might skip couple of values. So what it skipped, when I say 0 to 4, it got only 0 and 4, but it skipped all other records 1, 3, and 2. Okay, just keep that in mind, and you will have to practice this for you to understand what I'm saying. Okay, similarly, what we can do is, like, we can set index using ID. I think we discussed this part. So what I did, I set the index. Again, you notice the index is not in the increasing order. You have a different set of things. Again, when I use dot iloc on this particular thing, okay, again, it will do the same activity. It will fetch the second record. It will fetch the third record. See, it fetched the second record. It fetched the third record. When I use dot iloc, it will refer to the record count, not the indexes. On the other hand, if I use dot lock, the slicing operator, it will refer to indexes. Now this will fail because it cannot find 2 and 4. Previously this record was successful when I used this indexes, it was available, so it was throwing out. But now it cannot find these values 2 and 4, so it is throwing the error. But you can use dot log to find slicing like this. I want to fetch all the records between 1 and 2. So sorry, I got lost because of power cut. Are we good till here? I think we have a little more code to discuss. So similarly, if you want to, yeah, so I think we already discussed till here, right? From the slicing operator. Now I'll tell you about in place equal to true, okay? Let us say that I want to reset my index to back to normal. I'll take the same use case of temp df. Okay, and then I want to replace the index to normal. So what I'll do is dot reset underscore index drop equal to true. Just see what is going to happen now. I reset my index. So far so good. You can see the index is 0 1 2 3 4 again. Let me print temp df one more time. You notice the index is same. I reset my index, but it did not apply. It did not replace the variable that is sitting in my memory. It just showed what would happen if you reset. Now I want to apply this to the actual reference wherever my data frame is sitting in the memory, right? I want to go and rewrite that. Whenever you want to rewrite, that is when you go and use dot replace. Code, I'll just go and say, let us say I don't want to drop. I'll say drop equal to false, in place equal to true. Okay, when I do this, now when I go and print tempdf, you can notice that the whichever was there in my index, it has become as a column because I said drop equal to false, and it has replaced the data frame which is there in my memory. Okay, now I can see I have the ID, animal, count, and location. Okay, that is what happens when you use replace. But you can, the other way of doing it is you can assign this. Say I want to say temp df equal to. This is one more way of doing it. If you want to do it, if you don't want to use in place equal to true, you can assign it. But because we want to reduce the code footprints, generally we'll be using in place equal to true, and then it will apply back to the same variable. Okay. We can also subset based on position. Say, for example, we saw the slicing operator previously. What happened to slicing operators? Like when we say, I want to fetch all the records up to 10, it will fetch all the records. First 9 records it will fetch. You can see. Similarly, you can do it by using dot log. I want to use dot log and fetch only records 1, 5, and 7. If dot iloc 157. So what it will do, it will fetch the second record, it will fetch the 6th record, and it will fetch the 8th record. Okay, this is the second record, 6th record, and 8th record. Similarly, if I want to do it for HR2, I can also do the same thing. It will do the same thing. So it doesn't bother about what is the index value. It is just bothering about the record count. Usually we'll be using .iloc, but some cases we'll be using .log also. That is why you will have to understand both .log and .iloc. As I said, you will have to practice it. Only then you will get used to it, or else you will end up facing multiple errors. Okay. The same way how we use .log with indexes and columns, you can also use .iloc with indexes and columns. So you're referring to these record numbers and you're referring to these column names. So when I say column names 135, it understands that you're referring to IBM HR, say IBM HR dot columns. So it understands that you're referring to the second column, which is attrition. You're referring to fourth column, which is daily rate, and you're referring to sixth column, which is distance from home. So .iloc always refers to the positions where the value is present. It is not actually looking at the actual value. It doesn't look at index value or the column
Sanjeev,
value.
voice cut out, break out.
Okay, sorry. So what I'm saying is .iloc always refers to the record count or column count. Okay, it just keep that in mind. This is a column count. This is a record count. You're referring at these are the record counts. Okay. Similarly, you can use for HR2 also. You can do the same thing. Say for example, if you want to pick in a column, you want to pick only a couple of records. So you can do that by saying, say, this is my age. I want to fetch the first row. Okay, so 0 is not present. I can say dot iloc of 0. Like this, you can do it. Okay. So it is looking for the index value 0. If it is not present, then it will throw the error. Say, for example, if I use .iloc, it will not throw any error. Like if you want to do this, you can do that also. .iloc. Okay. On the other hand, if you want to look at all the null values that is present in the whole data frame, you can do that by saying .isNull .sum. So what it will do is first it will check for all the null values that is present in each column, then it will sum up. Wherever you have boolean, it will sum up. So if it is true, then it will consider it as 1. If it is false, it will consider it as 0. For this particular data frame, you don't have any null values. Just in case if we have such data, then I'll show you also how to deal with null values, how we can replace the null values in the next session. Okay, I think we should be good for today. This is too much. In the next session, I'll be telling you more about how to subset the data based on multiple conditions.